Hello, hello. We are back talking about example 4. But first we have to talk about what an angle bisector is. An angle bisector, there's that word bisect. Bisect means to cut in half. So you're basically cutting an angle in half. That's what angle bisector is. So a ray that divides an angle into two congruent angles or two congruent halves. So if you look here at this little picture here, this ray, JK, cuts this big angle, LJM, in half. So this little part is equal to that little part, okay? So we talked about that segment bisector in the last section, and I think we had like 5 different formulas. And the same is true for this, okay? So we're going to talk about 5 different formulas for this. So the first one would just be that this angle right here and these two angles, they are congruent, or they're equal to each other. So I'm just going to say that the measure of angle LJK is equal to the measure of angle KJM. So just these two are equal to each other. All right, that's one equation. Okay, another equation is that this small angle is actually half of the big angle. So the measure of LJK is equal to 1/2 the measure of the big angle, which would be the measure of angle LJM. Okay. The third would be, instead of looking at this small angle, let's look at this, and this would be half of the whole, right? So the measure of angle KJM is equal to 1/2 of the whole angle LJM. And then the fourth equation would be, if we look at the whole thing, right? So LJM, so the measure of angle LJM is equal to 2 of these, right? These are the same. So basically 2 of this same thing would equal a whole. So we'll just say 2 times the measure of angle LJK. And then the last one would just kind of be the pair to that. So the measure of the big angle, LJM, is equal to 2 times this one right here down there. 2 of those make up the whole thing because these are 2 equal. So 2 measure of KJM, like that. So those are the 5 formulas. So anytime you see angle bisector, you know all of these. And this is called definition of an angle bisector. So this really needs to be on a flashcard. Definition of angle bisector. So this needs to be a flashcard right here. All this information. Because we are going to refer to that for quite some time. That needs to be a flashcard. Perfect. All right. So example 4, it says finding the measure of an angle. So this says KM bisects. Boom. That's the key word. We know it bisects this angle, so we know that we're going to have access to all 5 of those formulas. So KM here bisects this big angle JKL. All right. It is telling us that the measure of JKM is 4x plus 6. And it's telling us that the measure of MKL is 7x minus 12. It wants us to find the value of JKM, this one. So we need to find this value. Right now it's giving us a value, but it gives us a algebraic expression. So we actually need to come up and figure out what x equals in order to determine what x is, and then we can substitute it back in there and then figure out what the value of JKM is. All right? So when we're looking at our different equations, right? Our 5 equations, what would they be? So the first one would be just setting these two things equal to each other, right? Because it bisects, that means these two things are equal. And sometimes I just like to write those little arc marks in there. And I really think that that's where we're going to end up with, is just this equaling that. So let's just go for that. First, we need to write down that given information. So let's go ahead and do that first. I'm going to say the measure of angle JKM is equal to 4x plus 6. And it also says that the measure of angle MKL is equal to 7x minus 12. All right. And then it also gives us this, KM, that ray bisects angle JKL. Now, all of this information here, this is all given information. The problem has given us that. And because we know this bisects piece, we can use that definition of an angle bisector and say that these two angles now equal each other. So we can say that the measure of angle JKM is equal to the measure of angle MKL because of the definition of an angle bisector. So we have our formula. Now we're just going to do substitution and substitute those values into our formula. So JKM is the same thing as 4x plus 6. So I'm going to write 4x plus 6 equals MKL is the same thing as 7x minus 12. Okay, so that's substitution. And then from here, I'm just going to use algebra and solve, right? I have variables on two different sides. I'm going to move the smaller, 4 is smaller. So I'm going to subtract, the inverse operation would be subtraction. Subtract 4x to both sides. Those cancel, left with 6 equals 7x minus 4x would be 3x minus 12. So that was a little subtraction property of equality, right? And then we did a little simplifying. Okay, we got to get x by itself, so we have to add 12 to both sides. We end up with 18 equals 3x. Those cancel, right? So that was addition, property of equality, and simplifying. And then we're going to get x by itself, so we're going to do the inverse operation of multiplication, which would be division to both sides. So division, property of equality. 3 divided by 3 is 1, so we get x on this side. 18 divided by 3 is 6. So that's simplified, but I want to go ahead and write x equals 6 and use that symmetric property of equality. So now I know what x is. But they didn't want just x. They wanted us to find what the value of measure of angle JKM is. So I'm actually going to take this all the way over here. And I'm going to say the measure of angle, what is it, JKM is equal to 4x plus 6. Right? That's that given information that they gave us. And then I'm going to use substitution. So now I know that 6 is equal to x. So I'm going to substitute this 6 in there. So I have the measure of angle JKM is equal to 4 times 6 plus 6. That's just called substitution. And then I simplify, right? So do order of operations, I got multiplication and addition. So 4 times 6 is 24. So measure of JKM equals 24 plus 6, and then 24 plus 6 is just 30 degrees. So that means the measure of JKM is equal to 30 degrees. And that would be the answer, and this was simplify. Perfect. There we go. That's how you do that problem. Let's go ahead and practice this a couple more times because that's a lot. It's a lot of information. So here we go. Check it out, example 4a. It says find the measure of each angle. This says QS bisects PQR. Well, we don't see a QS, so we're just going to draw it in. Okay, so I'm just going to draw in bisects. That means it cuts it in half. So it's going to cut in half right here. That means this side and this side are the same. I'm going to make this an S, and it's a ray, right? So it keeps going on. PQS is 5y. This is 5y minus 1. And PQR, the whole thing, is 8y plus 12. Okay, so what we need to do is find the measure of PQS, this part right here. So it gives us this piece and it gives us this whole, all right? So this is one of those ones where we want to go ahead and write down those 5 angle bisector formulas and figure out which one we want to use. So let's see here. The first equation is just to say this one and this one, this piece and this piece equal each other, right? So we would say the measure of angle PQS is equal to the measure of angle SQR, like that, okay? The second one would to say PQS, that is half of the whole. So measure of angle PQS is equal to 1/2 of the entire thing, big angle, which would be the measure of angle PQR. Okay, and then the third would just be this pair, right? Looking at this angle down here, this is half of the whole. So the measure of angle SQR is equal to 1/2 of the big angle, which is PQR. And then the fourth one would be to start with the big one, right? So the measure of PQR is the same as 2 times this one on top. So measure of 2 times the measure of PQS. Yeah, because 2 of those, they're the same, they're equal, right? So 2 of those equal the big. And then the last one is PQR, the big angle, is made up of 2 of these. 2 measure of angle SQR, like that. Okay, perfect. So what information do they give us? Well, they give us the PQS, right? PQS, so this is PQS here. PQS is also here. Where else do they give us PQS? Here's PQS. That's it. Okay, so that's our PQS there. And then they give us PQR. So where's PQR? Here's PQR. Here's PQR. And here's PQR, yeah. And here's PQR. So the one we're looking for is the one that has both of them highlighted. So here, we have this information, but we don't have that information. So we wouldn't use that equation. We have this information and we have this information. So we could use this equation. We have this information, but not that one, so we wouldn't use that equation. We have this equation and this information and this information, so we could use this equation. And this last one, we have this information, but we don't have that one, so we wouldn't use that. So really, we're going to use one of those two. Let's just go with this one here. Okay, then we, don't have to deal with the fractions. We can deal with the fractions. There's nothing wrong with fractions, but, let's just deal with this one. Okay, so the first thing we have to do is write down that given information, okay? So we have the measure of angle PQS is equal to 5y minus 1, comma, the measure of angle PQR is equal to 8y plus 12. And then the last bit is right here, this given information. Oh, I'll just write it here. QS, ray QS, bisects angle PQR. All right? And all of this is given information. Okay, perfect. So now that we have that, we can go ahead and write our formula. Let's go ahead and write this one. The measure of angle PQR is equal to the measure of angle PQS. Perfect. And we can say that because of the definition of an angle bisector. That's why we can say those 5 formulas, definition of an angle bisector. Okay, let's go ahead and plug in this information. So we know that PQR is 8y plus 12. So I'm going to substitute that in right here. 8y plus 12 is equal to 2 times the measure of PQS, which is 5y minus 1. All right, that's just substitution. Now I'm going to use the distributive property here. 8y plus 12, rewrite that. 2 times 5y is 10y. 2 times a negative 1 is negative 2. That's just distributive property. Okay, now I want to get the y's. There's y's, the variables on 2 different sides. I need to get it on the same side. I'm going to move the smaller, which means I'm going to move 8y to both sides. That cancels. I'm left with 12 equals 2y minus 2, right? So subtraction, property of equality. I simplified here. Perfect. I'm going to get y by itself, so I'm going to have to add 2 to both sides. 12 plus 2 is 14 equals 2y. Okay, so addition, property of equality. Trying to get y by itself and divide by 2 to both sides. That is the division, property of equality. I end up with 7 equals y. That's 1 times y, which is y. Let's just simplify, but I'm going to write y equals 7 and use that symmetric property of equality to do so. Okay, so now I know that y equals 7, but the problem wants us to find the measure of PQS. Okay, so I'm kind of running out of room here. So I think I'm just going to go, whoops, sorry about that. Where are we going to go? I'm going to go right on a little journey up here, okay? And so I'm going to write that the measure of angle PQS is equal to 5y minus 1, okay? I'm going to substitute that 7 in for y, so that's the given information, right? So measure of PQS equals 5 times 7 in for y minus 1. That's just substitution. And then I'm going to go the measure of PQS equals 5 times 7 is 35 minus 1, which leaves me with the measure of PQS equaling 34 degrees. And that would be the answer. All right, perfect. Let's go ahead and work on this last one here. This says JK bisects angle LJM. The measure of LJK equals negative 10x plus 3, and the measure of KJM is equal to negative x plus 21. Find LJM. All right, so the problem I see with this is there is no information. So whenever there's anything like this, I try to draw a picture. So I'm going to draw an angle here, And this angle is going to be called LJM. Okay. It says JK bisects, so that means it cuts in half, which means we have all of those 5 formulas. So JK, this is JK. So that means that this side is equal to this side. Those are the same. And then I'm just going to put in this information that they give us. LJK is negative 10x plus 3. And then they give us JKM is equal to negative x plus 21. And then they want us to find LJM. So they want us to find the big angle. All right, well, perfect. So here, this is kind of like a multi-step. Let's go ahead and write down all of our equations that we can from the angle bisector. So first, we know that these 2 angles are just the same, right? So I'm going to say my first angle is measure of angle LJK. LJK is equal to KJM. Measure of angle KJM. All right, the second equation would be that this one right here is half of the whole. So the measure of LJK is equal to 1/2 the measure of the whole thing, LJM. Okay, and then the third would just kind of be the pair, which would be the measure of this angle would be half of the big one. So the measure of KJM is equal to 1/2 the measure of LJM. All right, and then we're going to do the whole angle, the measure of LJM. LJM is equal to 2 of these, measure of 2 LJKs. And then the pair for that one would be the big angle. The measure of angle LJM is equal to 2 times 2 of these, make up the whole one, which would be the measure of KJM. KJM. Perfect. Okay. So for this first one, what do we need? They give us this information, right? And then we need to figure out what the big one is. Okay, perfect. So when we have these pieces of information here, LJK, that's right here, LJK, and this is JKM. So, I mean, they basically are giving it to us right there. So let's just start there, okay? And figure out what this X value is. So let's go ahead and write down our given information. So we have that measure of angle LJK is equal to negative 10 x plus 3. And we have the measure of angle KJM is equal to negative x plus 21. Okay, and then we also have this bit right here, JK bisects angle LJM, right? Okay, perfect. So all of this is the given information. After that, we can just go ahead and use this formula. The measure of angle, what is that? LJK is equal to the measure of angle KJM. We can say that because of the definition of an angle bisector, right? Then what we're going to do is just substitute those values in. So LJK is right here, so negative 10x plus 3 is equal to JKM, which is negative x plus 21. Okay, so that's just substitution. Perfect. We want to get the x's on the same side. We're going to move the smaller one. I'm going to say negative 10 is smaller than negative x. So I'm going to do the inverse operation and add 10 to both sides. That cancels. We're left with 3. Negative x plus 10x gives us 9x plus 21. So that's addition property of equality. Now we're going to get the x by itself, so we're going to subtract the 21 to both sides. That is subtraction property of equality. That cancels. 3 minus 21 would be a negative 18 equals 9x. Okay, then we're just trying to get x by itself, so we're going to divide 9 to both sides. And that would be division property of equality. And so we end up with negative 18 divided by 9, which is negative 2 equals x. And I'm going to write it as x equals negative 2. Okay, so that is that symmetric property of equality. Okay, so from here, we could just take one of these and plug x in. So let's just take, how about this one right here, KJM. So the measure of angle KJM is equal to negative x plus 21. All right, that is given information. And then what I'm going to do is just stick that negative 2 in for x. So I'm going to substitute it. When I do this, what it's going to do is it's going to give me a value, right? Negative times a negative is a positive, so that's just 2. 2 plus 21. So we had substitution, and now we're just simplifying. Okay, and so basically I have measure of angle KJM is equal to 23 degrees. Now I'm going to go back over here to my equations, right? I'm going to use a different color. So I know what measure of JKM is right now, right? So I know that JKM, I know that one. And I want to find LJM. So JKM is here. JKM is here. And then I want to find LJM. LJM is here. LJM, yeah, that's here. LJM is here, and LJM is here. So I want the one where they are both highlighted. So here, this one isn't, so that wouldn't work. This one isn't highlighted, so that wouldn't work. This one is, so this one I could use this equation here. This one isn't highlighted, so that equation wouldn't work. Or I could use this one. Okay, how about, let's just use this equation right here because it's already solved for LJM, and so that will make it really nice. So I'm going to use this equation here. Measure of angle LJM is equal to 2 times the measure of angle KJM. And I can use that equation because of the definition of an angle bisector. Once I have that, I'm just going to substitute 23 in here. So I have the measure of angle LJM is equal to 2 times the measure of 23, because this equals 23 degrees, and that's just substitution, right? Then we just do that math. So the measure of angle LJM is equal to 23 times 2. 23 times 2, 2 times 3 is 6, 2 times 2 is 4, 46. So 46 degrees. And that is our final answer. So remember, when you do all this work, you need to make sure that you show all your work and show all the steps. And wonderful job, and we will see you next time. Goodbye.